This video is the review for exponents and logarithms. In our problems today, we're going to look at compound interest and some other things. With the compound interest formula, the reminder is that P is always the initial amount that you start with. R must be turned from a percent into a decimal, and T must be the time in years. N is always the number of times you are compounding in 1 year. So for number 1, we have A is equal to 3,500 times 1 plus 0.065 divided by 12, because there are 12 months in a year, raised to the 12 times 10, because I have 10 years. The other thing that you need to be conscious of when you do this is if you're putting this in a graphic calculator, remember you have to force it to do order of operations. So for this parentheses, I need an extra set there, and I need to remember to put parentheses around my exponent. Otherwise, you may end up with multiplication before you wish for it to multiply. When I put that in the graphing calculator, I should get $6,692.64. If I put that in the continuously compounding formula, I'm going to have A is equal to 3,500 E raised to the 0.065 times 10. Again, you need to make sure that the exponent is in parentheses, and that number will get you $6,704.39. Please remember that continuously compounded interest will always be higher than the use of the first formula. If your calculations do not turn out that way, then you need to double check your calculations. You may have left off the parentheses somewhere. All right, as we continue with this, the second part of this asks you to do an exponential equation to a log equation. Now remember, the base here of your exponent is the base of your log. So this is log base 4. Your answer is what comes next, so 64, and then it's equal to whatever your exponent is. And if it helps, I will label these. So exponent, base, answer. Okay? If you're not sure, put that in the calculator and see if that's what it comes out to be when you put it in that way. The next one is log of base 25, because 25 is the base of my exponent. My answer is 125, and that is equal to my exponent, which is 3/2. Continuing on, the thing that people most often forget is to put these into exponent form and solve them. It does not matter which method you use to solve. You can put them in the calculator. You can do change of base and put them in the calculator. If you can straight put them in the calculator, if it's base 10 or LN or E, you can go ahead and put those in. But you must change them first into exponent form. So for this first one, I have a base of 10. Remember, your exponent is after the equal sign, so that's X, and that is equal to 1,000. So when you put that in the calculator, X is 3. For the next one, I have a base of 9 raised to the X is equal to 3, and X in this case is 0.5. For the next one, I have a base of 2 raised to the X, and that is equal to 1/8. So X is equal to -3. I have a base of 4 raised to the X, and that is equal to 1/4, so x is equal to negative. If you're putting these in the calculator, please remember that if you have something like this, you have to change the base. So you can either do log of 1/8 over log of 2, or you can say ln of 1/8 over the ln of 2 and get your answer. It does not matter which method you use, whether you solve the exponent or whether you simply put it in the calculator, that calculation is up to you. For the next couple of problems, you're simply putting these in the calculator, and the thing that most people forget to do is they forget to read the directions about how many decimal places they're supposed to be. So the first one is 0.663. I believe yours says to the negative 12, so it gives you a 0, because that is e to the negative 6, so you're going to have 4 zeros in front of your number. The next one is 3.118. The next one would be 1.019. The next one is 1096.633. And the next is 1.609. All right, number 15 refers back to what I mentioned about putting these in the calculator. You can either do change of base with log or change of base with ln. The choice is yours. It doesn't matter. You're going to get the same answer either way you do it. So what I'm asking you to do is I'm asking you to write the change of base formula with the log and then with the ln, and then put it in the calculator. So you're doing log of 9 over log of 4. Remember, base bottom. Or that is ln of 9 over ln of 4. And when you put that in the calculator, you get 1.585. For the next one, it is log of 200 over log of 12, or ln of 200 over the ln of 12, which is going to give me 2.132. As we continue through these, please pay attention to the number of decimal places. At this point, we're down to expand and contract. Remember, with expansion and contraction, with expansion, every term is going to have what is beginning the problem. So in this case, I have two things, and I can write this as log base 5 of 5 times x squared. So that tells me that I'm going to have two terms. Both of them are log base 5, and because this is multiply, then that has to be addition between them. So my first term is log base 5, and then my second term is x squared. Now, you have to remember that your exponent travels to the front. So the 2 goes out front, the x stays behind the log base 5. On number 16, I have two things. Remember that this can be written as x to the 1/3 power. That is taking the radical symbol out of that and changing that into a fractional exponent. So I have two terms. I have a top and a bottom. So I have log base 3 for both of those. And I'm going to have subtraction because I have division over here. So on the top, I have log base 3 of 6. And then I have an exponent of 1/3 for my second term, so he comes to the front and the x stays behind. On the next one, I have 3 different terms. I have 1, 2, 3 terms. So I'm going to have ln for each of those terms. And because I am multiplying between each, I know it is going to be addition. So I have an x squared, so